Hello, this short video will take you through some of the spatial analysis steps for creating map number 4. And before we can get into even a map creation, we have to load another plugin or extension that will be more helpful than the built-in program that's available with the QGIS. And this extension or plugin is called the QGIS. It's not loaded in by default, but you can actually go and install it because it does come with the QGIS package, and you can find it by going to plugins and manage and install plugins. And it's not installed, so you have to click on the not installed tab and search for QGIS and click on it to make it active, and then install the plugin, and it should install within a couple of seconds. And there it is. There's the actual pull down menu. This is going to be a little bit more helpful than the one that's already comes with the software, and then you can close the plugin window. Next, we're going to be downloading some data from the Michigan GIS library, and from the Fish and Wildlife Service we're going to download the Michigan counties from the GIS library, and you can find that at the Michigan GIS gis-michigan.opendata.arcgis.com website. And over there, under the data categories, click on the boundaries link and find until you see the counties. Let's see. Oh, here it is, counties version 17A. Click on that, and this is the one that you want. And then go to the download link and download it as a shapefile. It's going to be a zip file, and once you download it and unzip it, it's going to look something like this. Download it and unzip it, and you've got the files that go with your counties layer. The other data set from the Michigan Geodata Library site is the state roads, and you can find that under the transportation link. And let's see, scroll on down. Here's the railroads. And there are two road versions. Use the one that's called the state roads, because the all the roads contains all the roads in the state, which is a very big file. You can see it's more than 10 times the size of just the state-owned roads. The state-owned roads are going to be enough for this lab. So click on it, go to download, save it as a shapefile. Once you download it and unzip it, you'll get your state-owned roads files. And finally, we're going to go to the Fish and Wildlife Service, ecos.fws.gov, /ecp/report/table/critical-habitat.html. And it may take a second or two for this to load up. And download the first link, which is going to be a zip file containing two shape files, one for lines and one for polygons, which contain all the critical habitat shapes for all species. And you'll get a layer like this. Save it and unzip it, and you're going to get the files for the critical habitats. And we're going to be interested in the polygon layer. So we're going to do some analysis, try to find ideal critical habitat locations, that is locations in this case that are 1 mile away from state roads. So load up your data sets, going to layer, add vector layer, and browse to the let's see, we're in the downloads, counties, and load the counties layer. There are all the counties of Michigan. Browse to the critical habitat layers, load the polygon layer, not the line layer. And you see this contains all the area of the entire country, that is the critical habitats in the entire country. And let's load one more, the roads layer. State-owned roads, and load them all up. And there's your roads layer. Now you can see that the coordinate system we're using here is latitude, longitude. That's why the built-in analysis tool is not going to work, because we're not going to be using latitude and longitude. We want a 1 mile buffer, or find the critical habitat areas that are at least 1 mile away. And the built-in analysis that comes with the QGIS actually uses the same unit of measurement as the coordinate system. In that case, it's the latitude, longitude, or degrees are not going to work. With the QGIS, we can create actually 1 mile buffers, and we'll get to that later on. So this is the advantage of the QGIS extension, but we'll get to that later on. So in order to work with the critical habitats in Michigan, we're going to have to clip the critical habitats to Michigan. But in order to work with the entire state, we're going to have to merge the counties. And you can do that with the dissolve command. That is, we're going to be dissolving the boundaries between the counties in order to form actually just the outline of the state. So you can go to Vector, Geoprocessing, and Dissolve. Select the counties, select where you want to save it, save to file, and I saved it in my counties layer. And I saved it as Michigan. Save it as a shapefile type layer, and then click Run. And it may take a minute or two because we've got 88 counties where the borders need to be dissolved. And you can find what this command does. It takes a polygon vector layer and dissolves adjacent polygons into single entity. And there it is. There's my dissolved layer. I can zoom to it. And there's Michigan, the entire outline of Michigan without any state boundaries. So now we can remove the state layer. Right click and remove. Or we can remove the counties layer, not the state. Now that we've got the outline of the entire state, let's take a look at which critical habitats fall inside the state, and you can do that by just dragging this to the bottom. Oh, it's zooming in and out. Oh, yeah. And you can see that there are several critical habitats that fall inside the state. And we only want to use this habitat, it's not the entire habitat layer for the entire country. And we can do that using the clip command. Go to Vector, Geoprocessing, and Clip. We're going to be clipping our critical habitat polygon layer to our dissolved layer. That is, we're going to be clipping it to the outline of the dissolved layer. And save that to a file. I saved it in my critical habitat layer as Michigan Crit Hab. Mish Crit Hab. Save it as a shapefile. Click OK and run. Again, this may take a little bit of a time. But there's the clipped layer, and we can see the individual clipped layers inside Michigan. If I zoom to the layer, it goes just to the outline of Michigan basically. So I can remove actually this layer since I'm not going to be working with it. Right click and remove. And if you open the attribute table, you'll see that there are actually 3 types of critical habitats for the piping plover, Heinz emerald, dragonfly, and for the skipperling. And let's turn off the roads and the Michigan layer, and you can see that they're pretty much spread out across the state. And obviously that you can see that there are more than 3 areas. And in order to get an attribute for each area, these areas will have to be exploded into their individual component parts. And you can do this by converting the polygons to lines and then reconverting the lines back to polygons. So in order for each polygon to have its own attribute, or for each area to have its own attribute, first convert them to lines, and then from lines back to polygons. So go to first vector, geometry, and polygons to lines. You want to convert your clipped and save it to a file. I saved them in the critical habitat folder as crit lines. And then click run. So it converted them into lines. So these are closed lines, they're not polygons anymore. And now we're going to have to convert them back, geometry, lines to polygons. Convert the lines from polygons back to polygons. Click Save File, and I call them crit-pol. And I saved them in my critical habitat folder. And click Run, and that was pretty quick. And now you can see that they're back to polygons. Open the attribute table, and now you can see that each area has its own attribute. So even though the map doesn't look different, each area now has its own attributes. And we can remove the lines layer and remove the clipped layer. And now we can create the buffers around these polygons. And then we're going to intersect these these buffered areas with the roads layer, or to see where the buffered areas, if the buffered areas intersect the road layers. So this is where the extension comes in handy. So then you're going to create buffers out of your polygons from lines. And let's buffer it for 1 mile. And save it. I saved it to my critical habitat. And gave it the name as crit-buff. Save it, then click OK. And it may take a minute or two, but there are your buffered areas. And let's drag that below the polygons layer. And you can see that these are the 1 mile buffers. These are the 1 mile buffers for my polygons, for my critical habitat polygons. Now we will try to find the ideal habitat by intersecting this with the roads layer, intersecting the buffered polygons with the roads layer. And this is done by what's called the spatial join. The spatial join will check to see if there's any intersection between the roads layer and the buffered layer. This is under Vector, Data Management Tools, and Join Attributes by Location. This is also called the spatial join. So you're trying to intersect the critical buffered with the state-owned roads. And we're checking to see if they intersect. And scroll down over here, leave everything else the same, and save this I saved it in my critical habitat layers as crit buff int. And click run. And there you go. There's the there are the buffered areas. If we turn back the state roads, these are the buffered areas that actually intersect the roads layer. So these buffered areas are within 1 mile of a road. These ones with the greenish yellowish color are the ideal habitats. That is, they're more than 1 mile away from any state-owned roads. To save just these ideal habitats, you can use the difference command. Vector geoprocessing difference. So we're going to be using your crit buff and taking the difference with the crit buff with the joined layer, which is the intersected layer. And I saved these as crit buff ideal. And then run it. And there you go. That's the ideal habitat. These are the ideal habitats, and you can see if you zoom in that these are at least 1 mile away from any state-owned roads. And it's interesting to see that there are some ideal habitats in southeast Michigan, near Detroit. It's kind of unexpected. There would be more expected ideal habitats in northern Michigan near the Upper Peninsula. And we can label this, and by going to the properties, right click and go to properties, and go to the labels, turn on the labels, and label with the common name, the com name. And click OK, and you got the actual ideal habitats for, or the actual species at these ideal habitats. And you can also label the roads layer the same way. Go to properties, right click properties, click on the show labels, and use the use the road name, and click OK. And it may take a bit to load since there are several thousand state-owned road segments. And it's still thinking. Well, I guess it's taking too long, so we can go to properties and turn that off. If you want to label it, you can. But now you can go to the composer and create a nice layout. So go to project and new print composer. Give it a name. And let's see, go to go to layout and add the map. Oh, I didn't turn on the roads. I think there's a and turn on the Michigan map. Now let's use a different color for the roads. So you can go to properties and select a different color by clicking on the style. And let's turn the roads into red. And go to project and composer manager. Just open that up. There are the roads. They kind of show up. It doesn't show up very well, but you can actually see the roads. Maybe we need to make the roads a little bit thicker. So we'll right click and go to properties. And let's see, style. Select a different pen width. Make it a little bit thicker. Oh, there we go. So now let's go back to our composer. Composer manager and show. And there we go. It shows up a little bit better. So now you can add your labels and north arrow. Add label. This is going to be Lake Huron. You can check the font, make it a little bit bigger if you like. And label. Lake Michigan. Let's see if that works. It still doesn't show up. Add a scale bar. And add the legend. And add a north arrow. And then convert it to a PDF. Add your name and the date, convert it to a PDF, and that's going to be it.